So now what we're going to do is actually incorporate the logarithm into problems and some other little tricks to it. So you can see that this is chain rule. We have one big parenthesis here, but there's also a parenthesis here on the logarithm. Now that little x with a radical, we can leave it there and leave it as an x to the half and then use chain rule that way, or we can bring it out. So I'm going to leave it in there just the way it is to show you that it's fine to use chain rule, and then in the next one we will rewrite the function to make it work. Okay, so again, like what I like to do is take the parenthesis, highlight it, and then we do our derivative. So this is just be a normal general power, so y prime equals 3, and again everything in yellow you leave alone. Just like that. And then we take away 1, right? So then it's 2. So now we take that inside and we're going to take the derivative of it. All right, we do have another parenthesis here, so let's put it in parentheses. And you can even just rewrite it off to the side if you want, because you know you're going to have to take the derivative of that. Okay, so let's go back to this. Derivative of 5x is 5 plus, and then now we can do our little log thing. So that goes, the 7 goes on the top, right? The radical x goes to the bottom. And then the 9 becomes a natural log of 9. So just like that. Now we're going to move over to this guy, because we're going to tack him onto it. This is x to the 1/2. So that would be 1/2 x to the negative 1/2. So that's 1 over 2 radical x. So we tack it on here. It goes right there. Now we can do a little simplifying. This is 5 plus 7 over 2 x ln 9. Because radical x times radical x is x. And then we multiply it over here. So we put it in a parenthesis. If you do not have the parenthesis, you're not actually multiplying the entire thing, which is what's happening. So you see, each time you do chain, whatever the derivative of the inside is being multiplied to it. So this is the inside for our logarithm, so that's where we multiply it to. This entire thing is the inside for this power, and so that's what we multiply it to. There we have it. All right, so another way to do these as well, you can't actually on this one except for that guy. So what you could have done is taken the x to the half and rewritten it like this. So y equals 5x plus 7 log 9 radical x, right? And so instead of having radical x, we now write x to the half. And then we can use our log rule. So this is 5x plus, and then we bring the half in front, 7/2 log base 9 of x. And so you know this would become this, looks exactly the same, but look over here. If you look at it now, we can just save a step. So this is 7, 2, the x comes to the bottom, and you get natural log of 9. So you don't have to actually do all of that. So rewriting your logarithms can help out a lot. So if we did this, our derivative would still be exactly the same thing. So if we take our function here, and we put natural log of x plus 1 minus natural log of x minus 1. Remember, we're using that rule that allows us to separate them. So if it's a division, you put subtraction. If it's multiply, you put an addition. Now we have two separate logarithms. So this would just become 1 over x plus 1. And then derivative of x plus 1 is just 1, so we don't have to do anything. Minus 1 over x minus 1. And then the derivative of x minus 1 is 1. And there you have it. Now we can put them together if you want as well. So we're going to multiply this one by x minus 1 and x minus 1. And this one by x plus 1 and x plus 1, just to get one clean fraction. So this would become x minus 1, x plus 1. And then on the top, we would have x minus 1 and negative x plus 1. So x minus 1 minus x minus 1, because you have to distribute that negative to both. So this would become negative 2. So f prime of x equals negative 2, x minus 1, x plus 1. See, it's a lot nicer than leaving it in that form. All right, and then now just to make sure we have all the rules, we'll do another one. So on this one, we can actually bring that exponent in front. So this is 3 ln x squared minus 1. So now it's one clean little problem. So remember, 3 goes on top, x squared minus 1 on the bottom, and then we apply our chain rule. So this is 2x, so we multiply by 2x. So putting this together, y prime equals 6x over x squared minus 1. Product rule, same thing. You want to locate the x's. So if you see that there are two x's, this is product rule. It's not one function. So we're going to do e to the x and ln of x. And I threw those in there just because those are the two we're doing in this chapter. So e to the x, 1 over x. And then we do our little multiply. So this would be e to the x ln of x minus, plus, e to the x over x. You see how that works? Just like before, it would just be e to the x over x. Pretty cool, right? And you can factor out that e to the x if you want, and you can write f prime of x equals e to the x ln of x plus 1 over x. Either one is fine for an answer. And there you have it. So there are some more complicated problems. So I really recommend rewriting the logarithm first. It just makes things a lot cleaner.